This video is going to be a review for your Unit 0 tests. So our first topic that we're going to be reviewing is evaluating expressions. To evaluate means you're going to plug in a number for your variable and simplify or make it smaller. So here on example 1, we're going to plug in 10 everywhere we see an A and 3 everywhere we see a B. So our A becomes a 10, our B becomes a 3. And then we can simplify our answer. So here 10 times 3 is 30, so this becomes 5 plus 30. And on the bottom 10 minus 3 is 7. So we get 35 over 7. If you divide, you get 5 as your answer. On the next example, we're going to plug in -3 for x and 4 for y. Here, if I do 6 times -3, that's -18. And 2 times 4 is 8. So my problem becomes the absolute value of -18 minus 8. Now if I do -18 minus 8, those are same signs, so we add and keep. So we get an absolute value of -26. And we learned that absolute value, whatever's in it, always becomes positive. So in the end, the absolute value of -26 becomes a positive 26. The next topic we're going to cover is simplifying expressions. Simplify means to make smaller. We're going to do this by distributing and combining like terms. So here, we're going to start with 6 times 2x, that's a 12x. And then 6 times 5y is positive 30y. On the next one, the signs here are important. So I'm going to treat this like a -3. So -3 times 20y is -60y. And -3 times -4x becomes a positive 12x. Now that I've distributed, I want to combine like terms. So I'm going to put the terms that are like next to each other. So I have 12x and a positive 12x, a positive 30y with the -60y. So I'm combining like terms. Now if you do 12x plus 12x, that's 24x. And 30y minus 60y would be -30y. And remember, there's different ways you can write your answer. So another way you could write it is you could actually switch your terms. And you could put the -30y first and the positive 24x second. That would still be correct. This next topic we're going to review is solving equations. So here we're solving for a variable. So in the first one, I would distribute. -3 times 5x is -15x. And -3 times -6 is positive 18. From here, my x is stuck or attached to the -15, so I have to do -18 first. So I'm starting to undo to get x by itself. 48 minus 18 is 30. And my next step, they're multiplying -15. I would divide both sides by -15. So now that x is by itself, our solution, 30 divided by -15, is -2. Problem 2 has variables on both sides. When there's variables on both sides, you want to undo one of them first. So we have to decide if we want to undo the 6x or the -2x. I like to undo the smaller one. So the opposite of -2x would be positive or plus 2x to both sides. So we get 3 plus 8x equals 27. Here the x is stuck to the 8, so I want to undo my positive 3 first. So I would do negative or -3 to both sides. 27 minus 3 is 24. And then my last step here to undo multiplying 8 would be to divide 8 so that x is by itself. So my final answer is a 3. The last equation here has a square root. Remember, to undo square root, the opposite is to square. So we're going to square both sides, because what you do to one side, you do to another. So the square root and the square cancel. And I'm left with 4x minus 3 equals 7 squared means you're doing 7 times 7, which is 49. So here my x is stuck to my 4, so I'm going to have to do plus 3 first. And then you could divide the 4. So my final answer for x, if you divide 52 by 4, would be a 13. Another topic that we covered was slope and y-intercept. So in number 1, we're just identifying our slope and y-intercept. So if you remember, we learned y equals mx plus b, where m is your slope, b is your y-intercept. So here, our slope would be -2, that's our m. And our y-intercept would be +6, that's our b. Question 2, they gave us a graph, so we're going to have to analyze the graph. So if I want to know my y-intercept, I like to start with that. I look at where it crosses the y. So 1, 2, 3, 4. It crosses up here at about 5. So this would be my y-intercept. It equals about 5. Then to do slope, you do rise over run. You need to pick at least 2 points. So I'm going to look for another point that is on this graph. So let's say I use this one right here. Once you have your 2 points, you want to check, always start at the left. And you want to check from there if it's going to go up or down, because that gives you your rise. So to get from this point on the left, I'm going to color it a different color so it's easier to see. Let's do green. To the right, we would have to go down 2. And to the right, 1, 2, 3. So since we're going down 2, right 3, our slope would be -2 over 3, because we're using rise over run. So to summarize for this one, our slope, or our m, is -2/3, and our y-intercept, or our b, was at about +5. So when you write your equation, y equals, the slope goes first, -2/3 x, and our y-intercept was a +5. If you look at example 3, here they're checking that you understand parallel and perpendicular slopes. So they gave us the equation of a line, y equals -3/4 x plus 6, and they want to know the slope if it's parallel. Remember, for parallel, we learned that the slope would be the same. So right now, if we look at our problem, the slope is -3/4. So the parallel slope would also be -3/4. For perpendicular, we learned that the slopes are opposite reciprocals. That means that you change the sign and flip the fraction. So if our slope here was a -3/4, we would change it. So we have -3/4. We're going to change it to a positive, and if we flip it, it becomes 4/3. So the perpendicular slope would be 4/3. Another topic covered was laws of exponents. So we're going to start with a multiplication rule. So here I'm going to start with my coefficients. I have 6 times 2. That's a 12. So I'm going to put a 12 in my answer. Then I have x cubed times x to the 8th. If you remember, when you multiply, you add exponents. So if I add them, I get x to the 11th. Then I have y to the 5th times y. Remember, if there's no exponent, you put an imaginary 1. So if we add those exponents, we get y to the 6th power. So if you're multiplying, you add your exponents. Number 2, they're dividing. When you divide, you subtract your exponents. So if we break down number 2, I would start with my coefficients. 18 divided by 3 is 6. So I'm going to put a 6 in my answer. Then I have x to the 5th over x. Remember, if there's no number, you put an imaginary 1. So when we divide, we subtract. So 5 minus 1 will give me x to the 4th. Then for my y's, I have y to the 6 over y squared. If we subtract, that'll give me y to the 4th power. So my answer is 6x to the 4th, y to the 4th. Again, if there's no exponent, you put an imaginary 1 to help you. The last problem here is going to go over power of a power. When you have power of a power, you multiply your exponents. Here I'm going to break it down. So basically, I'm going to do everything to the 3rd power. So I have 4 to the 3rd power, which means 4 times 4 times 4. That comes out to 64. And then I'm going to take x to the 6 to the 3rd power. Here you multiply your numbers. So 6 times 3 will be an 18. So I get 64x to the 18th. The last topic we covered was factoring trinomials, so quadratic trinomials. So here, this one starts with x squared. So I'm going to set up my factors beginning with x. And then when I do my blanks, my top one's going to equal my c, my negative 24. My bottom one equals b, which is 10. Now I'm going to make a list of numbers that multiplies to 24. Once you have a list, you want to see which of these can add or subtract to give me 10. Here it could either be 2 and 12 or 4 and 6. So if we wanted to use 2 and 12, we would have to subtract them to get 10, meaning one of them would have to be negative. If you wanted a positive 10, you would have to use a positive 12 and a negative 2. That'll give you 10. If we check, 12 times negative 2 also gives us negative 24. So this first pair works for both blanks. So since I have a positive 12, I'm going to put a plus 12. And since I have a negative 2, I'm going to put a minus 2. And those would be my factors. For this one, 4 and 6 wouldn't work because you would have to add them. So you would have to add 4 plus 6 to get positive 10. But if you do 4 times 6, that's positive 24. We want negative 24, so this one didn't work. Question number 2 here is also factoring, but this time there's a number in front of x squared. So when I begin my factors, I put a 3x. Remember, we're going to fix that step in the end. Now I can do my blanks. This time for your first blank, you need to multiply a times c. So 3 times 20 gives me 60. My bottom blank is my b, or my negative 7. Now I can make a list of numbers that multiplies to 60. Once you have a list big enough, you want to look at them and check if there's one of those that adds or subtracts to give us 7. So if I look at my list, I can use 5 and 12, because if you subtract those, you get a 7. So I'm going to use a 5 and a 12.
Yeah, it's right here.
If I want a negative 7, I would have to have a negative 12. Sorry, I just realized I made a little mistake here. I believe I wanted it to be a negative 20 in the problem, so let me fix that. sorry, this should have been a negative 20. So that's going to make this a negative 60. Sorry. So now from there, if I look at my numbers for 5 and 12, if I want negative 7, my 12 would have to be negative. 5 times negative 12, or sorry, 5 plus negative 12 is negative 7. And if you do 5 times negative 12, you get a negative 60. So sorry about that. I had done a typo when I wrote it. So now I can write my final answer. Here I have a positive 5, so I'm going to put plus 5. Here I have a negative 12, so I'm going to put in minus 12. And remember, we're not done. We're going to have to do one last step where we divide to make these factors correct. So if we look at 3 and 5, both of those can only be divided by 1. So that factor is going to become or stay 3x plus 5. Our next factor, you can divide both 3 and 12 by 3. So that would become a 1x minus 4, or just x minus 4. So those would be our two factors for this problem. If you were to check it, 3x times x gives you 3x squared. 5 times negative 4 gives you negative 20. So that matches your A and your C term. Usually when that happens, it means you did it correct.